We will go through assignment 5, and the first question that we will go through is question 3. And as usual, I will not post solutions to anything that I go through in class, but I don't think we will get the chance to go through all questions. So the questions that we will not get the chance to go through in class, I will post solutions for them. So for this question, please take notes. Okay. So, like I said, this was a question on a test. Find the first set for x, y, and e. First of x, first of y, and follow of e. Okay. First of x. So we look at x. This is the definition of x. What's the first thing that you should definitely go into first of x? First of a. So we go to take first of a with epsilon or without epsilon? Without epsilon. We will put an epsilon in first of x only if all of these three have epsilon. Okay. Now, next. So should we consider b or not? Why? Because a has an epsilon. So because a has an epsilon, then we consider b. And we put first of b, again without the epsilon. So we put c and d. Now, should we consider c? Yes. Why? Because b has an epsilon, so we consider c. So again, we put the e without the epsilon. But then we say, okay, a, b, c, all three of them have epsilon. Therefore, x, the entire x, can be an epsilon because all of them can be epsilon. Because I have epsilon, epsilon, epsilon. This means that the whole thing, this is the logic of it. Because this can be epsilon, this can be epsilon, this can be epsilon. Therefore, the whole thing can be epsilon. Now I put the epsilon in first of x. Okay? Am I done with x? No, there is another definition of x that I should consider. Okay, now the other definition, I should first put first of d, definitely, because obviously an x starts with a d. So what's in first of d? An f. Should I consider the e? Why not? Because there is no epsilon in first of d. Okay, so here, no epsilon, I stop. Again, the logic for this is all very intuitive. If you can never substitute an epsilon for a d, so you must substitute something for a d, this means that an x will never start with an e. Okay, so now for x, I'm done. For the first of x, I'm done. For the first of y, the y starts with a b, so I put c and d. Because there is an epsilon, I consider the d. Then I put the f. Do I consider the a? No. I stop as soon as there is a no epsilon. So this is a no epsilon, so a y will never start with an a, according to this definition. Okay? So then this definition tells me that a y can start with a y, and the y doesn't have an epsilon in its first set, so I will not consider an e. So I just close the y. Now, follow of e. Now follow is, let me clean this up so that we can look into the follow set. Okay. Follow of y. So I just look for y on the right hand side. So I scan for y and for e. So this is an e and this is an e. So these are the e's that I consider to find the follow of e. I look at where it appears on the right hand side and what comes after it. Now, What comes after an E here? X. So logically, I should put first of X in follow of E, because an X appears after an E. So I look at first of X. First of X, which is this. A, B, C, D, E. Should I put the epsilon? No. An epsilon never appears in a follow set because it doesn't make sense for an epsilon to appear in the follow set. Because the follow set means the symbols that follow a string derived from this non-terminal. And it will never be followed by nothing. It's either followed by another symbol or followed by end of file. That's the only thing that can appear in a follow set. Okay, so now I put first of E. Now, should I consider first of X? We put the first of X in follow of E. So now what should I do next? Now, what if I had something after the X, like Z? Should I consider first of Z or not? Well, does X have an epsilon in its first set? Yeah, X has an epsilon in its first set. So if I had a Z, I should have considered it. But I don't have a Z. Okay. But now what should I do next? Follow of X. Why follow of X? Because this can be epsilon. This X can be epsilon. And because this X can be epsilon, this means that the E can be the last piece in an X. And if it can be the last piece in an X, then I should put follow of X. And follow of X, I just copy all of this stuff. A, B, C, D, E. I already have all of these. Then I add G and H. Okay. Now I'm done with this. Now I look at this. What does this tell me? Put follow of Y in follow of E. Put follow of Y in follow of E. Why? Because E is the last thing in a Y. And follow of Y is AGH, which I already have. So in fact, I should have written this as first of X minus epsilon union follow of X union follow of Y. Okay, so these are the first and follow sets. Then left recursion. So we need to eliminate left recursion. Where do we have left recursion in this grammar? In Y. In X there is no left recursion, right? There is right recursion. So, one mistake on the test was trying to eliminate this, even though it's right recursion, not left recursion. Making it left recursion or something. I don't know. But it's the only left recursion that I have is this. So this is my left recursion, Y and Y. Now, again, the rule for left recursion elimination is, let's use a symbol that is not here. So I'm not going to use X or Y. I'm going to use or A and B. What can I use? Z. Okay. So Z alpha or beta. This gets converted into Z goes to what? Beta Z prime, where Z prime is alpha Z prime or epsilon. Okay, now where is my beta? This whole thing is a beta. This is my beta. Beta is the non-recursive definition. And where is my alpha? E. This is my alpha. Okay. Now I apply the rule. So this goes into y, goes to beta, which is b, d, a, c, y prime, such that y prime is alpha, which is e, y prime or epsilon. Okay? And then I get rid of this. Okay, because I apply everything to this rule in addition to this rule. Okay, so now the next question is left recursion elimination. Find the first and follow sets of the new variables that you have introduced in part 2, which is what's the new variable that we have introduced? Y prime. So I need first of y prime. What's first of y prime? This is the definition. What does the y prime start with? It starts with an e, so I put first of e, and first of e is g. Okay, do I consider y prime itself? No, because this doesn't have an epsilon. Am I done with first of y prime? No, there is another definition which says explicitly that y prime can be an epsilon. So there is an epsilon. So this is the first of y prime. Now what's the follow of y prime? The follow of y prime, I look at these y primes and I see what comes after them. So here I don't see anything after this. So what should I put in follow of y prime? Follow of y, because this tells me y prime is the last piece in a y. So I put in follow of y prime, follow of y, and where is follow of y? Follow of y is here, so I just copy it. A, G, and H. Okay. And then this tells me that put follow of y in follow of y. So this is useless, doesn't tell me anything. And then I'm done with follow of y prime. Okay, so checking the LL1 conditions. How many rules do I have to check? Do I need to check this? Yes, why? Because I have two alternative definitions of x. Do I need to check this? No, because I have only one definition of y, so there is no need to check this. Do I need to check this? Yes. So I have two rules to check. So I check this, x. So I need to do the first plus of the rule x goes to ABC. And the first plus of this rule is going to be the first. If this whole thing goes to epsilon, does this whole thing go to epsilon? Yeah, so ABC, they all have epsilon, so this whole thing can be an epsilon. In this case, the first plus is not the same as the first. The first plus is going to be the first of ABC union what? Union what? Follow of x. And first of ABC is first of A, then I look at first of B, then I look at first of C, because they all have epsilons. So this is going to be long. So first of ABC, first I take first of A. First of A is AB. Then I look at first of B because of the epsilon, and it gives me C and D. Then I look into first of C because of the epsilon, this gives me E. And because all of them have epsilon, I put the epsilon. And then follow of x. What's follow of x? Follow of x is this thing. So I already have A, B, C, D, E. What do I add? GH. This is the first plus. So I compare this first plus with first plus of what? First plus of x goes to DEX. Okay. Now, does D have an epsilon? No, it doesn't. So this reduces to what? Just first of D. First of D, which is F. Now, I take the intersection of these two first pluses. What's the intersection? Intersection is phi. So the first plus union, the intersection is phi. This means that we are good. Okay. Okay. So now, next, I need to check the first plus of what? Y prime goes into EY prime. And is this, okay, is this first plus just the first of E? It's the first of E because it doesn't have an epsilon. So this is just first of E, and first of E is G. Now, first plus, what's the other first plus? Of Y prime goes into epsilon, and this is directly what? Follow of Y prime. And follow of Y prime is, where is follow of Y prime? Oh, here. ADH. Now, what's the intersection? Intersection is G. So, G. This means that it's not LL1. Okay. So this is the procedure for LL1. So how many people got this right, or you don't know? You got this right? Okay. Yeah. So anyway, the more people will get this right in the quiz, the faster I will grade. So I will be done with it. So because it's always easy to grade an 100% correct solution. If there is a solution that is not 100%, then I will have to debug it. So it's this is the biggest problem with grading is when you have a buggy solution. You have to debug it and then identify the bug and then decide how many points to deduct for that bug. So it's a lot of debugging, and that's why perfectly correct solutions save me a lot of time. Okay, yeah, question.
Oh, yeah. My question is, for first plus of Y prime going to epsilon, do you include the epsilon because it's first of epsilon? And then
Oh, that's okay. That's a good question. Yes, you can include it, but it will not matter because there can be only one alternative that has an epsilon in it. If there are multiple alternatives with epsilons, then it will not be LL1. So the result will be the same whether you put the epsilon or not, but that's a good question. Okay, questions? Okay, so should we do let me do question 4. Why question 4? Because I'm not gonna do the derivation. I think the derivation is straightforward, but trying to do the things that we did not do in class. I think I will get the chance to do question 4 and question 1 or 2, one of them, and I will do 2 because it's different than what we did in class. More different, yeah. Question 1 is very similar to what we did in class. Question 2 is less similar to what we did in class, so I'm going to do 2. But I will first do question 4. So question 4, apply left factoring. I mean, we did this in class, so I'm not, this is straightforward, just the way we did it in class for the left factoring. And you don't have to do left recursion elimination, just left factoring. Do the derivation. I'm going to skip this, and I'm going to do part 3. Part 3, which is extending the grammar, because it's something that we didn't do in class. So extend it so that it starts with a statement. And then the statement is either an assignment or a conditional. An assignment or a conditional. An assignment consists of an expression. It's very straightforward, by the way. Assignment consists of an expression assigned to a variable using the equal operator. So it's a variable identifier equals expression. Does it say semicolon? Yes, it says semicolon. So this is an assignment. Identifier equals expression. The conditional a conditional is the if keyword. So at this point, the whole if is a token that comes from the scanner. So this whole thing is a terminal, is one terminal, right? At this level, the if is a terminal. Keyword followed by a condition between parentheses. Condition between parentheses. Followed by an arbitrary number of statements between braces. So let's call this statement list between braces. Now it remains to define what, we need to define 2 things, the condition and the statement list. Condition is what? The condition, you can have any of these, exactly 2 expressions with these, using these operators. So it's going to be condition, it's going to be expression, operator, expression, where expression is defined as above, and operator is one of these operators that are given, equals equals, or not equal, or greater than, or less than, or less than or equal, or greater than or equal. Did I put all of them? Yeah, okay, I put all of them. So this is, so what remains now? Statement list. So how do we define a statement list? Using recursion, right? Because an arbitrary number of statements, so we just use recursion. So we can say statement. So in fact, this you can do with left recursion or right recursion. It's not asking you to eliminate left recursion. So you can do left recursion and just keep it. So statement list, statement or epsilon. Yes. Because does it say it can be empty? Just stick. It doesn't say if it can be. Yeah, arbitrary includes 0. Yeah, it's not. Yeah, it should be interpreted as 0 statements is possible. So it's either statement, statement list, or epsilon. So just recursion on statement. Of course, this is still not. What are the limitations of this definition? What are the limitations of this definition relative to real programming languages?
You can have multiple conditional.
Yeah, so here the conditional is just greater than or equal. You cannot have or and or. So in a programming language, you can have and or, and you can have an arbitrary number of these. Let's call them comparisons. So any number of comparisons with and or, right? So this is limited. It just tells you that you can say something like this. If x is greater than y, that's it. This is okay, but this grammar doesn't accept if x is greater than y and z is greater than 5. It does not accept this. And in order to extend it to do this, you can do something similar to what we did with arithmetic. What we did with arithmetic expressions can be extended to logical expressions. But in logical expressions, instead of having plus, minus, multiply, divide, we have and or. So the and plays the role of what, or corresponds to what in arithmetic? In terms of precedence, I mean. So we have add, subtract, multiply, divide. And in terms of precedence in logical operators, the and has higher precedence than the or, right? So in order to construct an expression, a logical expression, basically what you do with the and divide, you do it for the and, because this is the high precedence. And what you do with the add and subtract, you do it for the or. Okay. So basically, you can define a logical term and a logical factor, or a Boolean term and a Boolean factor, and then what you do with the add and subtract, you do it with the or. What you do with multiply and divide, you do it with the and, in order to construct a logical expression. Okay, so I have time. I will first do question. Okay, so how many people had problems with the derivation? Should I do the derivation or should I do the question 2? So how many people want the derivation? Yeah, the derivation 3. Yeah, the parse 3. Okay, how many people want the parse 3? Okay, 3. How many people want question 2? Okay, so more people want question 2. So let's do question 2. Question 2. Okay, S is SAA or CAB. A is BA or epsilon. B is plus S or S, and C is A or B. BA, okay. So now what's the question? The question is compute the first and follow sets. I think I gave this question on a test. I can't remember, test or homework. And some students tried to eliminate left recursion, which doesn't exist. So there is no left recursion here. So if there is no left recursion, you don't have to eliminate anything. So don't create left recursion and then eliminate it. If it doesn't exist, you don't have to worry about it. Okay, so there is no left recursion. We need to calculate the first and follow sets. What are our terminals here? The T or sigma. Here I have open parentheses, close parentheses, A, B. These are our terminals, plus star, and that's it. These are the terminals that we have. Okay, so let's start with first of, what would be the easiest thing to start with? C, definitely C, because it's obvious. The first of C is just A or B. Now let's look into B. First of B is either plus or star or the first of S. Now what's the first of S? We haven't computed that yet. So we will wait until we get to first of S. By the way, sometimes you may need multiple passes when there are dependencies. So let's put first of S, and then whatever goes in first of S should go into first of B. Now what's first of S? Can we calculate this completely at this point? Well, we know that open parentheses should go in first of S. And then should we consider first of S, first of A? No. First of C. So what's first of C? We haven't. Oh, we have. So first of C is A or B. Are we done with first of S? Yeah. It will not. We know first of C 100%. It's not going to change. And we know that this is just open parentheses. So first of S is done. And since we have to put first of S and first of B, so we just add these three symbols to first of B. Don't forget that. Okay. So are we done with, yeah, we are done with B as well. So we are done with B, we are done with S. It remains to do what? A. First of A starts with a B. So first of B, we just put everything in first of B. So we put first of B plus star open A, B. Everything in first of B goes into first of A. Should we consider first of A? Well, first of A is first of A. What else? Epsilon. Epsilon, yeah, because there is this option. Okay. What else? That's it. So we have S. We have A, B, S, C. That's it. Now follow sets. We always start with follow of start variable. Follow of S is always, we always put what in it? End of file. But of course, we may have other things besides end of file. So in this case, we find S on the right hand side. So here's an S, here's an S, here's an S. So what does this tell us? S is followed by close parentheses. So we put close parentheses after the S. And we are done. We don't go to A. Why? Because there is no epsilon. So this close parentheses, you can think of this as a symbol, like call it what? Call it Z, and the Z equals this, and it doesn't have an epsilon. Okay, so we're done with this. Then we look at this. What does this tell us? put follow of B in follow of S. So follow of B yet to be computed should be put in follow of S once we figure it out. We haven't computed it yet. So that's fine. And what does this tell us? It also tells us the same thing. It also tells us to put follow of S in follow of B, follow of B in follow of S, which is something that we have already taken a note of. So let's try to attempt to calculate follow of B. And B doesn't appear here, it appears here. What is it followed by? Followed by an A. So we put first of A without an epsilon. First of A without an epsilon is going to be this whole thing. Without an epsilon. And then, we're looking at follow of B. So it's followed by an A and without an epsilon. First of A without an epsilon is this. And then what should we do? Yeah, and we should also put follow of A. Why? Because this thing has an epsilon in it. So we should look into follow of A. So follow of A should go into follow of B. So we put follow of A into follow of B, and we put that into follow of S. Don't forget these dependencies. And now, so we already know things that we should put in follow of S. We should put plus star open parentheses AB. We should put all of these, take them from follow of B, put them in follow of S. Now, follow of B so far is dependent on follow of A. So let's find follow of A. What's follow of A? We look for A. So this tells us what? Put small a in follow of A. It's clearly followed by a small a. And here it's followed by little b. And here, what does this tell us? Put follow of A in follow of A, useless. Okay. And now we know that follow of A is complete. Right? We know exactly what comes after an A and B. So what should we do? We should put follow of A in follow of B, but it's already there. A and B are already there. And that's it. So we just look into follow of C now. What's in follow of C? C is followed by an A, so we put first of A without an epsilon, and that's going to be AB. So C is followed by A without an epsilon. Should we put a B, small b? Well, it's already there anyway. We should put it, but it's already there. So this is what follows a C. Is there another C? No. So we know that we are done with follow of C. And we know that we are done with all of them. Okay. So now we computed the first and follow sets. Is it LL1? So we should apply the LL1 rules or checking. So this topic is not hard, but you have to do it carefully because it's easy to make mistakes. It's easy to forget something. So make sure that you don't forget anything when you do it. So just do it carefully. make sure that you don't forget anything, because it's easy to forget. All right, so is this grammar LL1 justify? Okay, so what are the rules that we need to test? So we need to test, wow, lots of them, all of them. So each one of them has multiple alternatives. So first plus of S goes into SAA is what? Clearly this is what? Open parentheses. And first plus of S goes into CAB. This is first of C, and first of C is AB. And the intersection of these two is what? Is phi. So we are good. Next. First plus of A goes to BA is the first of B. First of B, and first of B doesn't have an epsilon, so it's just first of B. So this is going to be first of B, which is plus star AB. And first plus of A goes to epsilon is follow of A, and follow of A is AB. Now the intersection of these two, what's the intersection?
AB.
Intersection equals AB, which is not phi, so it's not LL1. So we can stop. Should we stop or not? It depends on the question. If the question says do all of them, then do all of them. And yeah, it says all of them. Check all productions. So yeah, so let's check the we don't have to, but okay. First plus of B goes into plus S is going to be what? Clearly plus. First plus of B goes into star is going to be what? Star. First plus of B goes into S is going to be what? The first of S, and the first of S is AB. Now the intersection, there is nothing common, but the intersection between any pair. So let's say intersection for any pair of these three is phi. So the intersection between this pair and this pair is phi. The intersection between this pair and this pair is phi. So you have to take the intersections with all pairs. Right? So taking the intersection of the three is not right, because there may be something wrong between two of them, but it's not common among the three. And if it's common between two, there is something like here. If I add, say, a plus here. If I add a plus here, the plus is common to this and this, so it's in the intersection between these two, but it's not in the intersection of the three. So taking the intersection of the three is wrong. It doesn't have to be in the three. It suffices to be in the intersection of two of them to make this grammar not LL1. So this is not LL1, or the intersection is not. Oh, sorry. So with what we have, the intersection is phi, so this is good. And here, first plus of C goes to A is A, and first plus of C goes to B is B. So this clearly passes. Okay, so first plus of C goes to A equals A, and first plus of C goes to B is B. And intersection equals phi. Okay. Any questions before we end the lecture?